How you doing? Welcome to our first chemistry lesson. Today we're going to be doing reversible reactions, dynamic equilibriums, and closed systems. Okay, so start off with reversible reactions. Quite simply, a reversible reaction is one where the reactants can be made into products, but also the products can be made back into the reactants. Okay, and we use this this double arrowhead to show reversible reaction. So normally we would show a reaction with a single arrowhead, just like this. So just a single arrow that shows just the reactants going for the products. But this double head shows you've got a forward reaction and a reverse reaction, where the reactants are made into the products and the products can be made back into the reactants. Okay, so let's have a look at a couple of examples. First one here, we've got ammonium chloride. This is actually an example of thermal decomposition reaction. So ammonium chloride, we've got the forward reaction produces ammonia and hydrogen chloride, and the reverse reaction, they cool down and make ammonium chloride. Okay, so the first reaction is thermal decomposition. So we heat it up into these reactants, and then we cool these reactants back down, goes back into the products. Okay, something which is really important to note down is that there's always an exothermic and an endothermic. So if this forward reaction is a thermal decomposition reaction, obviously heat's being released, so that's exothermic. But that would mean that the reverse reaction is endothermic. So we're cooling these guys down, taking energy in, and yeah. So this final example here, we have hydrated copper sulfate into copper sulfate and water. So again, use that reversible arrowhead. This is actually a really important reaction, something you will come across quite frequently. This is used as a test for presence of water. So this would be white. So copper sulfate is white. Okay, so with the water and the copper sulfate, this substance is white. Goes into the product of the hydrated copper sulfate, and this is blue, and that shows the presence of water going from white to blue. So that's a very common example. Okay, let's move on to what a closed system is. Okay, so quite simply, imagine you've got two conical flasks, and we've got a reaction in the bottom of both of them. In this reaction, let's say we've got a metal and an acid, so let's say sodium and hydrochloric acid. If it's an open conical flask, then potentially these reactants could react with substances in the air. So some of the reactants could be reacting, or some of the metal could be reacting with the air instead of just the acid, which is what we want. So, but that's an open system. But if we look here, and we have a conical flask with a bung in it, we have, again, let's say sodium metal and HCl reacting. Obviously, if there's a bung in it, then it cannot react with the air, so the system is said to be closed. This is just a really very good at viewing it. Okay, so that leads us on to dynamic equilibriums. So I've broken it down into 4 steps here. So we have step 1, A plus B, so these are the reactants. We go straight forward. At this point, we only have reactants, so no products at the moment. Then we go to step 2. We have the reactants are forming the products. But as we know from a reversible reaction, some of the products can be made back into the reactants. So that's what's happening here. So we can see that some of the products, just a little bit of them, are being made back into the reactants. Okay. Step 3, we can see by looking at the length of these arrows that this reverse reaction so that the product's being made back into the reaction, is happening at a greater rate. And this is because if more reactants are being made into products, then there's more products to go back into those reactants. Final step, you'll see the arrowheads are at the same length, and this is what we call a dynamic equilibrium, when the rate of the forward reaction equals the rate of the reverse reaction. Okay, and yeah, so dynamic equilibrium is just a reversible reaction in a closed system. So the reactants cannot react with anything else, they're just reacting with each other, and they form what's called an equilibrium, or they might call it dynamic equilibrium. Okay, that's all we've got time for today. Hope you learned something new or enjoyed it. See you next week. Thanks, bye.